Okay, so now we're going to eliminate the parameter, and we have exponential equations. And they happen to be with base e, and that's okay. Let's assume that we like the parametric equations, first of all. So let's say we like that, and we like that, and we just want to graph it based on the parametric equations. Then you would set up a table with t, and then you would have x of t equals e to the negative t, and you would have y of t equaling 3e to the t. Now, I did this earlier just so I could have some points to show you. But if you put in -2 for t, you wind up getting an ordered pair. So I'm going to skip the in-between part. You can do that with a calculator. But if you put in -2 for t, you get about 7.4, 0.4. So this is the ordered pair, right? So it's way out here at 7.4 and up a little bit. Something like that. Okay. And then if you put in -1 for t, you get 2.7, 1.1. Now, if you have questions where these are coming from, it's coming from these equations here. So I had to do it on a calculator, and I was just saving some time in the video here just to, say, okay, put that in a calculator with t being -1. Okay, 2.7, and then it's up a little bit. Okay, maybe there. Maybe a little more over. Okay, if I plug in 0, that's a nice one, right? I'm going to get 1, 3. So now I'm going to plot that point, 1, 3. So what I'm doing is I'm just picking some values for t and finding the ordered pairs so I can get an idea of what the graph looks like. And then I'm going to put in 1, and I got the point 0.4, 8.2. Okay, so it's going to be like up here someplace. And so I get this graph kind of looking like that somehow. Now that's just if I were going to use the parametric equations. But now they're telling us to eliminate the parametric equations. We'll start with the one that's a little more simple. So x equals e to the -t. Okay? That's going to be the same thing as x equals 1 over e to the t. Now, notice that the other equation has an e to the t in it. That'll be useful to us. Okay. So we'll do a little bit of algebra work here, and you're going to get e to the t equals 1 over x. Okay, now we're going to go to that equation that I just lost, which said y of t equals 3e to the t. Okay, but now we can replace this. So we're going to have y equals 3 times 1 over x, or 3 over x. Y equals 3 over x. That's the Cartesian equation. Now that should look familiar. It's one of our library of functions, right? It's a reciprocal function. So you could plug in some values. You could plug in 0 is undefined, right? So you'd have an asymptote here. So this is kind of back to some things we did previously. You could plug in 1 and you get 3. You could plug in 2 and you get 1.5. And you could plug in 3 and you get 1. And so you get this curve like this. And then you also, though, if you were to plug in negative values, so if you plugged in -1, you'd get -3. And if you plugged in -2, you'd get -1.5. And if you plugged in -3, you'd get -1. Oops. And so you get the matching part over here. So you notice the two curves look a little bit different. Hopefully this part looks the same as this. There was a restriction that t had to be greater than 0, so we're not going to be using this part of the graph. But and the function, the arrows, are going this way with respect to time. Okay, so that's that one.